RefCell allows us to follow the Interior Mutability Pattern. Interior Mutability is a design pattern that allows us to mutate data even when there are immutable references to that data. This is typically not allowed, as we learned earlier in the course, so this does use unsafe code to bend Russ's usual rules of mutation and borrowing. RefCell's rules are enforced at runtime, meaning the compiler typically won't catch any errors for us. So if an error is presented at runtime, then our program will panic and terminate. So let's begin to look at an example using RefCell. The first thing we need to do is import it in, and it is in standard cell RefCell. And now we will create a new struct called flagger, and this is just going to be a simple struct in order to demonstrate the idea behind a RefCell. So we're going to have one field called isTrue that's going to be of type RefCell, which is looking for a Boolean. So now we will say let flag equals flagger is true RefCell new, and then we want our Boolean to be true in this case. So when we use RefCell, we gain access to two methods, borrow and borrow mute. Borrow returns the smart pointer as a ref to t, so borrow returns ref t, and then borrow mute returns ref mute to type t. And both of these implement dereferencing, so we can treat them like regular references. So we'll say let reference equals flag.isTrue .borrow, and now we will print this out to make sure that the value of true is what was borrowed. And we have true. So now we can comment this out, and let's do a mutable borrow. So we'll say let mute ref equals flag.isTrue.borrow mute, and then we will dereference it. That way we can access the value inside of here, which in this case is currently true, so we want to dereference it to have direct access to it, and now we want to change it to false. Dereference first to access inside. And now when we print this out, we expect it to print out false, which is what we got. So we were able to mutably change an immutable value. And now what happens if we comment them both in and then rerun it? So when we comment it in and rerun it, we see that it ran fine, and then it panicked. So when we have them both commented in, we get an error stating that it was already borrowed. And this is because it wasn't checked at the compile time, but it was checked at runtime. So we cannot have multiple borrows out unless we pair it with an RC. So let's see what that looks like. So we will change here to be RC, and then reference, have a RefCell inside of it. And now we will say RC new and now we can say our new reference here, we'll just delete all of this, is RC new flag.isTrue.clone. And now when we run this, we will need to make that in debug mode. And now when we run it, we see that we printed out a RefCell which points to the value of true. So now we have created another owner pointing to our RefCell, which is holding the value of true. And if we wanted to change the value through our shared owner, we can do it this way. So we can say let muteRef equals reference.borrowMute, and now we can change it to false, and now we can print it out again, and it will print out and run just fine, and we have the same results as we did earlier. So let's summarize really quickly on when to choose box, RC, or RefCell. So RC enables multiple owners of the same data, whereas box and RefCell only have single owners. Box allows immutable or mutable borrows checked at compile time. RC allows only immutable borrows checked at compile time, and RefCell allows immutable or mutable borrows checked at runtime. And then because RefCells allows mutable borrows checked at runtime, you can mutate the value inside the RefCell even when the RefCell is immutable. So again, smart pointers are very powerful in allowing us to manipulate data and store it on the heap and allow us to do a lot of very unique things with the values inside. And so we will be able to take these concepts and apply them in the next section when we start to talk about concurrency.